of that. And the first thing I would do as a student say, hold on, Professor, I've never seen a pi over 16. You must have made a mistake in constructing the exam. I've seen pi over 4, I know that. Pi over 3, I know that, Professor. I know pi over 2. I've never seen a pi over 16. But what's the obvious answer? What is it without any thought at all? I don't care whether it's a pi over 16, 4 pi over 9. I don't care what it is. What's the answer? Well, it's got to be 1. Because sine squared plus cosine squared is always equal to what? 1. So watch out for little things like that on the test that may throw you there. So that was brought up. Now, besides that, let me jump right into where I should be. Yeah, here we are. We're in chapter 6. Hopefully, a lot of chapter 6 will be done here tonight. Mr. Party, they have, I'm going to try to give them 2 hours. Close to 2 hours. So give me a good time here to stop. Where I may have to stop tonight.
5:30, 5:20.
5:30?
Yeah.
How many minutes do I have then?
Right now.
Mr. Berkeley, how many minutes do I have?
Then the test time will be an hour and a half, 50 minutes.
I have,
You got like 20 minutes left.
if I give an hour and 50, I'll have how much minutes, how many minutes myself?
24 minutes.
I may go just a little bit over that. Okay, so just not too much. Guys, on a recap, and this is what slows me down sometimes, but I think it's beneficial. I have not seen you guys for a while. And I don't think any of us on our weekend, long weekend, I don't think we were thinking about inverse sine, inverse cosine, inverse tangent. I don't think we were. But we were doing this. So guys, right quickly, this, let's call it X. This, we were discussing last week. And Michael, if I recall, I think I gave the class a handout. You were reading certain parts from the handout. Now, a little reminder, if I do inverse sine X, you guys can look back in your notes here, the domain, in other words, that X, what can I replace X by? It's restricted. -1 to 1. Does anyone recall what the range was on an inverse sine?
Negative pi over 2 to pi over 2.
I love it. That's why those other professors are hoping you guys would sign up for their Math 7 class, or have signed up for them. Exactly. So coming out for an answer, it's got to fall there. If I do an inverse cosine, here's a restriction. Domain, what am I allowed to put right there? There's a restriction. Again, -1 to 1. Now guys, the range, Roberto, do you remember the range for the class for inverse cosine?
0 to pi.
Beautiful. Gotta be. And the last one I'm holding you responsible for, guys, is inverse tan. The interesting thing about inverse tan, what am I allowed to replace X by? It's open. It's all real numbers. That's one that's unusual. Range, Roberto, what was it?
Negative pi over 2 to pi over 2.
Not included. There's some asymptotes involved here, so those are not included on this one. And guys, inverse secant, inverse cosecant, inverse cotangent does exist. In case you go to a calc class and that professor mentions it, it does exist. I'm holding you responsible for these 3 major ones, okay, that we discussed last week. Now, what can I do right quickly with this so I can move on? I have here, get things connected tonight. If you're asked to find inverse cosine 1/2, this is all going to be on the final exam. All right, and maybe a little extra credit next Wednesday. Guys, what you're going to do is go to inverse cosine and say, wait, now the domain should be between -1 and 1, Professor. Well, my 1/2 does fall between -1 and 1, so I've satisfied the domain. Now the range you give me must fall between 0 and 180, or 0 and pi. Now it's got to be something you recognize. I'm not going to have you use a calculator. Does anyone recognize where you have seen cosine itself equal to a 1/2? The x coordinate. Pi over 3. Now that's 60 degrees. Now if his answer of pi over 3 is 60 degrees, I'll store it in degrees here. Does it fall between 0 and 180? If it does, we're okay. We're done. Finished. Next one. Let's put all these together here. I brought in this one. Inverse sine, move back into this, of this. Negative radical 3 over 2. Now I'm doing inverse sine. Now down here. The number I've placed here for my domain, the x replacement must fall between -1 and 1. You guys can play around with this. It does fit, so there's an answer. The answer for inverse sine must fall here. Between negative pi over 2 and positive pi over 2. As I'm talking about this, guys, let me do this right, if I can. Some students prefer those restrictions be written like, Professor, if I'm caught here, what are you saying? I'm caught either in quadrant 1 or quadrant 4. So if your answer does not fall in quadrant 1 and quadrant 4 there, you can't use it. For inverse cosine, I'm caught between 1 and 2. 0 and pi. This one, inverse tan, quadrant 1, quadrant 4. If that would help. Those are your locations. Now back to this one. Does anyone think they recall where have you seen inverse sine, the sine, equal to negative radical 3 over 2? Let me ask you this to get back into it. Of the 4 quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4, of those 4 quadrants, where is sine negative to begin with? Which of the 4 quadrants? The y. Sine y. 3 or 4. So I think, okay, 3 or 4, Professor, I see 4 here. If by restriction, maybe I'm in quadrant 4. And guys, does anyone recall the angle down in quadrant 4, which you must know for that final exam? Whose y coordinate sine is sure enough negative radical 3 over 2. Come again. I hear negative pi over 3. Who gave you that? Negative pi. Johnson. He says it's negative 60 degrees. And by the way, if he gives me an answer of a negative 60 degrees by inverse sine, here we go, guys. It should fall here or here, and this is in quadrant 4. And also, it is caught between these two numbers. Okay, so it satisfies everything. So that's a little recap, real quickly. But with that said, be careful in case you ever see this. Inverse cosine, and I'm going to move on here, 2. If I look back at my restrictions here, inverse cosine right here it is, my domain, the x possibility has to fall between -1 and 1. Okay, I give you a 2. Does 2 fall within this restriction? No, so I'd quickly say here, there's no solution. There is no answer. Now I know, and you know, you've never seen on the unit circle an x coordinate, which is cosine, equal to a 2 to begin with. That's another way to think about it. I guess with that, part B, let's try to make some connections here shortly. Yes, first one. I'd like to evaluate on the exact answer for this. Sine of inverse cosine 1/2. So watch carefully, guys, as I move through this. Mr. Park, keep watching the time for me, just let sort of warm me, okay? Sine of inverse cosine 1/2, guys, inside there, it's almost like a composite. I would suggest you do that first. What angle out there has for a cosine 1/2, that's what it translates into. Guys, does anyone remember, and for inverse cosine back to this, the answer's got to fall between 0 and pi, that I'm looking for. Quadrant 1 or quadrant 2. And since quadrant 2 cosine is negative, I can't use quadrant 2, is that true? So it's a positive 1/2. So the answer I'm looking for is in positive, quadrant 1. So does anyone think they remember the angle in quadrant 1 whose x coordinate cosine is 1/2? pi over how much? 3. Do we agree? No, I shouldn't put that's the answer. That's what was given to me, that's this part. You still have on the outside to finish this up, sine of that. Now, does anyone recall what the y coordinate was? Sine at pi over 3. Radical 3 over 2. And after all, that somewhat of a little composite problem, the final answer is, after the thinking, is this. But you gotta think about what's going on here. Number 2. Now watch carefully on this one. I have now, let's try to find tan of, let's try secant. Secant of inverse tan of 2. In fact, I'll put negative 2, make it even more interesting. Negative 2. Secant of inverse tan, negative 2, like a composite between two functions. Let's look at the inside here, guys. This means, and we'll translate for you, it means there's an angle out there whose tan is negative 2. That's what it means. Inverse tan has restrictions of, where am I? It's got to be either in quadrant 1 or quadrant 4. That angle I'm looking for has got to fall here. So right here I have a restriction. So that's got to fall between negative pi over 2 and a positive pi over 2. By restriction. Quadrant 1, quadrant 4. Now, please tell me, has anyone seen on the unit circle, you know y over x, that's tangent. Has anyone, or would anyone think on the unit circle, with all those angles on that circle, that when you place the y over the x, you get a negative 2? If so, name the angle for me. Place y over the x, you get negative 2.
Negative pi over 4.
Now, if you say negative pi over 4, now let me just deal with pi over 4 first. Michael, here we go. Pi over 4 has for coordinates these, if you just look at the basic graph of that basic function. Is that true? Now, if you place y over x, I think you get a 1. Don't you? Radical 2 over 2 over another radical 2 over 2, everything cancels. You get a 1. I want a negative 2. It's not there. It's not there. So all of a sudden you go to another class and you say, oh wait, they said it was there. There's an answer. Now I got to do a little thinking here. It's not one of those angles we're so accustomed to, so we've got to do a little translation here. First, guys, we do this for you. This says there's an angle out there that when you take its tan, like I said earlier, gives me negative 2. And I cannot find the angle myself unless I use an inverse tan key on a calculator. Can anyone tell me what is going on here? What might lead me to the answer, even though I cannot find the angle? And you gotta watch out for this on the quiz exam tonight. Any ideas? On this return from the holiday. Is there a relationship between secant and tan? Somewhere, have you seen a relationship? Maybe I should use the word identity. Is there something that at least connects them? I may not be able to find the angle I want here, but is there something you've seen in the past that connects secant and tan? Maybe with the help of an identity.
1 plus tan squared equals secant squared.
I forgot it. Here we go. 1 plus tan squared. She tells me, Professor, that's secant squared. That works for all angles. When I use that, I don't know what the particular angle here in size is, but she says that's true. Now look at this. If that's true, look at this. 1 plus tan is negative 2, so she says put negative 2 in here, Professor. Look at this. This is the way you do math. And if I square that negative 2, I get a 4. 1 plus 4 is 5. Mr. Parker, get ready for you in a second here. This is secant squared. We're looking for secant. And if I do a square root, looks like it's square root 5 secant theta at this point, guys, it's plus or minus, I gotta decide which one it is. After I do a square root on it, I'm gonna assume it's plus minus because I see a secant squared. Which quadrant are we in? Inverse tan is -2. Are we down in quadrant 4? And what is secant down in quadrant 4 of 1 over x? Look at all this thinking you gotta do. What is 1 over x if you're down in quadrant 4? What is the x coordinate from middle school? It's positive. So that means it must be this. Mr. Park, do me a favor, since you're gonna check this for me real quickly, I gotta be careful. Go ahead and find the inverse tan of a -2, which a calculator would be required. And tell me actually what's the size of that angle, which my class could not find. What was it?
-63.
Close to -63? Now, would you take secant of it? You did this in degrees. Find secant of a -63.
2.2.
2.2.
Yeah.
Now find square root 5. Well, Mr. Park, the square root key.
2.2.
2.2, yeah. Jeez, this guy is off the front wheel already. And the reason what we have. But there's the answer without actually knowing the angle. Who on earth? I don't know anything about 63 degrees. But that's what the angle was here, so I did not really need it to find the answer. I had to relate it with an identity. Okay. Let's see if I have one more, then we'll leave this. I do have one more. Number 3. Okay, Bart, I'm gonna ask you to check this one and finish. Last one here, guys. Tan of inverse sine, and I have 1/3. Now, I'll tell you ahead of time, guys, save me a little time here. You've never seen on the unit circle sine, the y coordinate, with a 1/3. You've seen a 1/2. You've seen a radical 2/2, but not 1/3. There's something going on here. Can I find it? I don't know it myself, or the angle. And then they're asking to find the tan of it. Now, does anyone have a relationship? Brianna, you gave me that beautiful relationship for tan and secant. This one may be a little bit tougher. Guys, does anyone have an idea how to get started with an identity? Because I'm sort of stuck. Which identity would you, it may take a couple of identities on some of these. Which one might you want to start out with? Give you sine to be 1/3.